Hi, welcome to Project Geospatial. I'm Adam Simmons, and with the Geospatial Frontier Virtual Technology Fair, we're bringing on Chris Tucker to talk about the data behind the book, A Planet of 3 Billion. So Chris has been with us on the podcast before, I would say a month and a half ago, talked specifically about a Planet of 3 Billion. Awesome book, by the way. He gave us a great synopsis of what that's about. Can you give us a brief overview before we dive into the data itself?
Oh, yeah, sure I can. And it's okay if I drink beer since I'm outside at my tiki bar?
Free country. Go for it.
All right. Well, I appreciate it. And thanks for having me on. Thanks, everybody, for tuning in from, wherever you're tuning in from. Really appreciate it. So you guys were kind enough to have me on to talk about the book. So I'm going to restrain myself and try to not give like a massive pitch on the book itself so I can focus on the data sets, because that's what always gets short shrift. Typically, I'm talking to a bunch of folks that aren't necessarily map nerds. So it's really nice to have, what I'm assuming are a whole bunch of map nerds there out in the interwebs listening. So the book really, I'll just put it in historical terms. So about 3 weeks ago, we celebrated Earth Day, and that was the 50th anniversary of Earth Day. The first one was April 22nd, 1970. And what's interesting is that in 1970, there was actually a whole lot of awareness about population, runaway population, a lot of hand-wringing about it, because people recognized that from the beginning of the 20th century to the middle of the 20th century, certainly by 1970, there was already a doubling, more than a doubling of the world population. From 1.6 to about 1.6 to 3.7, right? So that's more than a doubling by 1970. And what's interesting is 50 years later, we are suddenly awoken to things like climate change, but a lot of the other big concerns from the first Earth Day kind of faded into kind of distant memory, including population. But yet, 50 years later, there's another doubling of the world population. So, not a trend line that is sustainable in any way, shape, or form. And unfortunately, in 50 years later, just population has receded into, kind of the background, not as something that people are focused on. So 25, somewhere halfway between the first Earth Day and this Earth Day, 25 years ago, I actually attended a lecture for the inaugural lecture of Columbia University's Earth Institute by Joel Cohen. And Joel Cohen had a book called How Many People Can the Earth Support? And it took me a quarter century before I could come up with my answer. So my book is my answer to the question, how many people can the Earth support? Is that an answer?
Yes, it is. Sorry. I just want to double check. Stand by. We're doing a quick audio check on myself.
Uh-oh.
Okay, yep, I'm good to go. I can hear myself on the.
I can hear you. What happened there, maybe if you put your beer background on, people could hear you better.
Well, I could do that real quick. Stand by.
Should also crack open a beer. Anybody who's listening, you should crack open a beer. There you go. See,
there you go. Put my beer background on. So I know I got some, just to talk about the beer on here, I got some Black Ox from Old Ox Brewery just down the street from me.
Are they sponsors of Geospatial Frontier?
Unfortunately not.
Oh, that's okay.
I might be more of a sponsor of them.
There you go.
So with that said, no, that's a great synopsis. And the talk about the concerns of overpopulation and what to do with that. So what I find fascinating, and we briefly talked about this in the podcast last time, is basically how much data went into your research. And that was just crazy amounts of research and the best practices that you have to go along with that.
Yeah.
I think you have a lot of stories to tell with just bringing this book together and the people you had to interview along the way, right?
Yeah. Well, and, kind of the first question, it's interesting because I think with the big issues of the day, climate change, et cetera, we actually are not all on the same sheet of paper. We don't adhere to the same narrative. We don't all kind of think of where we are in the course of the story in the same way. And so one of the things I thought was super important was simply answer the question, when you say, how many people can the Earth support? The first question that comes to mind is, well, what do you mean by the Earth, right? Because people think about Malthus and, how many people can you feed? And that's not what I'm talking about. It's how many people can you throw on this planet, but yet have a planet capable of generating kind of the natural resources, the ecosystem, goods and services we need to support humanity as a species. And so the first thing, when I was doing my research, I knew what I wanted, but I didn't know it existed. And it turns out I had this fantastic research assistant from George Washington University, Sudie Brown. And I told her, about the biome literature and, all these ecosystem and, mappings by biogeographers. And we were working in the 2017 timeframe. And one of the first things she did, she came back with the newly minted Ecosystems 2017 data set. And it kind of answered a bunch of my questions. And the thing I really cared about was not like generic biome description saying, here's a kind of a desert, here's a kind of grassland, and here's a kind of an estuary. What I wanted was the unique ecoregions. Well, a term that, I kind of became more familiar with. And when I started doing the history on this, this started with work in like the late 1960s at the U.S. Forest Service, where they were mapping the forest ecosystems. Then it started getting picked up by the EPA. And if I can switch, I won't do it now, but if I switch into browsers, I can start pulling up websites for you. Where they're trying to understand, how do we delimit these ecosystems geographically to understand them from like a resource management perspective. But it wasn't until kind of the early 2000s that World Wildlife Fund and many of the kind of global conservation crowd started putting together, based on that U.S. government methodology, a global data set. So here is what's called ecoregions data set. And I have a little video. And the reason I do this video is, each of these places have a name, right? These places, if you're a local, you know what it's called. If you live, of course, in the United States, you may have no knowledge of this place on the other side of the world and kind of what makes it tick biologically, biogeographically. So it's useful to have just a little tour. But if you Google Ecoregions 2017, there's a website that you can actually just spend hours and hours or days and days kind of reviewing the hundreds of different ecoregions that are out there. And so I really started with this and went and met with a gentleman by the name of Eric Dienerstein at an NGO called Resolve. And they're trying to, understand conservation, what needs to be conserved, what is the human footprint on it. Though they had a somewhat different, they're answering different questions. They had a different quest. But then quickly, I also realized it's not just kind of terrestrial ecoregions, but we have all of these marine ecoregions. Now, this was done kind of by the same crowd, but, the oceans guys and the land guys don't necessarily run in the, in the same gang. So, you had to kind of hunt down the other website that happened to have this data set and find the guy that knew, where the styling file for that shape file was. And what's interesting here, right, is, well, more than 70% of the world is marine, right, is ocean. So, they were really only able to do kind of these coastal ecoregions. And when you'd ask about the deep sea, you would see kind of their footnotes saying, we know those are ecoregions too, but, we don't have the time and resources, money to kind of pull this off. What's interesting is if you ever look at the GPS on the sharks or orcas, that have been tagged, they're going all over the deep oceans, from ecoregion to ecoregion.
So does this mean when you're factoring in ecoregions into your book, and this is this is actually a live question from the audience, by the way. Does that mean that you're factoring in the Earth's ability to sustain wildlife too?
Yeah, completely. I mean, I actually don't separate them. So I think one of the weird fallacies of probably the past couple hundred years is we think of like humanity as not a species, right? So it turns out that we as a species, and I'll get to this in some of the other maps, started out as a very small number of individuals in that species and spread across the world. And, sometimes I like to not so really joke, that humans are the ultimate invasive species, because we started in one place and then spread across to all these other ecoregions. And, for millennia, we were very light. Our touch on the environment was very, very light. But over time, as we industrialized, it became heavier. So when I talk about the ability of, the Earth to support us as a species, like the key thing is these ecoregions have to be able to function themselves, and it's flora and fauna and, terrain and water and climate, everything kind of working together with geographic integrity. So, if the species of that ecoregions aren't somehow able to function, then all those complex relationships between the flora and fauna and the landscape, are undermined. For sure. So, go to the, what do I got here? I think I've got this. So, when you talk about, those ecoregions, the next thing you always want to talk about is kind of the human footprint. And that's kind of what I jumped to. And a lot of the data that had to be assembled, these are things everybody knows about. Where do you find the roads file, right? But part of it was a cartographic challenge, because if I put every single road, those little gray squiggles are all the roads. If I put every single road, everybody who's a geo nerd here knows that the map would kind of be black with roads at this scale.
So it would look a lot similar to a population map in that.
Yeah,
and
that's
then
right.
why bother?
That's right. And then, the big black smudges there are intensive agricultural zones. So, you have to pick a color. I was insistent to my cartographer that they not be colored green, because, people go, oh, it's green, it's nature. And you go, no, I'm pro agriculture. I always point out I came from an agricultural family, but you have to be fair and recognize that everywhere that is that black smudge, you have deleted the historic eco region, right? You've deleted the historic wildernesses in order to do productive agriculture. We've just done so much of it to support so many people that we've kind of annihilated large chunks. The red is the global population. There's several sources of that, whether it's gridded population of the world, from Season, some of the work from ORNL. And I will say, we use different products at different times. And there's good work from the European Space Agency that has built a temporal data set starting from kind of early Landsat, like 1974, I think 75, 85, 95, 2005, 2015. So, it would have been really nice had we had Landsat, 50 years earlier, because that's right when the global population kind of did an uptick. And there's really nobody's done good work reconstructing what's called a gridded population of the world pre-remote sensing. I would love to see somebody do their dissertation on that and synthesize a pre-Landsat gridded population of the world. Or if somebody's seen it, please send it to me. And then we've got the yellow or the orange, whatever you want to call it, on the coastal areas. Those are all dead zones, hypoxic zones, where the nutrients has flowed from the agricultural areas and from urban areas. And there's so little oxygen there, dissolved oxygen, that marine life can't survive. Now, again, I'm kind of lying with maps. Sorry, I'm pointing at my maps from up close. It's not that every inch of those coastlines is hypoxic, but at this scale they are. Right? There's more than 400 dead zones across the globe. And then I like to skip one more slide. Oop, am I in the right? There you go. Because then you have to look at the ocean garbage. And this is one of the harder ones. I mean, there's a lot of there. Actually, there weren't many good sources of it. And some of the folks, this has to be modeled, right? This isn't remotely sensed, because I guess nobody's really come up with a good remote sensing methodology for identifying ocean.
Well, besides looking at ship traffic, who's really looking at the ocean besides these really low resolution images, right?
Right.
That even if the low resolution images, you don't get a lot of images in the ocean. Period. You just don't.
No, that's right. So you get like the sea surface temperature guys that are looking at El Nino, and there's more and more oxygenation, because it's not just those hypoxic zones on the coast. There's actually big, messy swaths of low oxygen zones that are being exacerbated by sea surface temperature and climate change. Sometimes people will say, I mean, some of the analysis, the data says at high season, right, because it's seasonal based on heat and north-south, et cetera, up to 1/10 of the world's ocean will be have insufficient oxygen for marine life, which, that's kind of a depressing thought. But this yellow stuff here that I don't have on the previous map is a modeled version of the ocean garbage. And there's some fascinating data sets out there. There's a scholar in Japan who had been releasing rubber duckies, and you could see where they would end up, and you could kind of model various how the debris released here would end up somewhere else. But this is kind of the best one I found. And of course, right, it's subject to the color ramp and the intensities that you put on there. But this is real garbage. I always like to point out that nobody knew that there was ocean garbage really until 1996, right? Was that a quarter century ago? When a captain was crossing the ocean, and instead of at the helm, he was on the bridge, or instead of on the bridge, he was down on deck and said, "Look, that's a lot of garbage." And then he just kept looking, and it was, I guess there's garbage across the entire Pacific Ocean. So nobody really noticed that. Now it's there's TED Talks on it. You'll find all sorts of stuff about ocean garbage, but there was no remote sensing methodology to put it together. So it's kind of this point sampled, ocean current based, modeled out version of things. But I think this is unfortunately terribly accurate.
So what would you say would be the recommendation for collecting data on ocean garbage? What would you say would be a good methodology for that?
Ask your audience. I don't have the answer. I mean, I would love to have it.
I'm not looking for an answer. I'm looking for hey, what if we can get this type of curiosity?
No, I hear you, but I've got
I think almost like a because he's obviously a planet who paints the world in terms of landmass, but I'm wondering, I think in a more ideal sensor would be something like a daily revisit for a SAR going over the ocean or something like that, but no one's doing that right now.
Yeah, no, I mean, I'd love some remote sensing nerds to get on top of this and start selling it to Congress or European Space Agency or somebody. I think there's definitely probably a spectral element to what do plastics look like, floating in an ocean versus just regular water. The other curious thing, that kind of came out in the research is there's all of these chemicals out there that are hydrophobic, like they hate water, and so they jump onto the plastic and bond with the plastic. So when the plants or when the animals eat a lot of the plastic, like those little, maybe some of the women will remember, there were these face scrubs out. They've been banned since, but these face scrubs had these little micro plastic beads, and then they'd go down your water system into the rivers out into the ocean. So the oceans are filled with these micro plastic beads. Well, it turns out they look like fish eggs. So turtles eat them, and then you'll find turtles and other animals with enormous.
I recall something like a lot of West Coast states where I remember maybe 10 or 15 years ago were trying to advocate using those beads to help prevent evaporation of certain open water reservoirs.
Those are big. I think they put big beads on top. I think they put balls on top. I don't know.
It's the same technology, right?
Yeah. But I mean, if you've got all of this stuff that kind of looks like some natural thing, but it's plastic, and then all these hydrophobic chemicals that are jumping on the plastics, you'd think there's something that would be remotely sensible, right? But I haven't seen anybody do it. I would think if it's spectral, maybe the Modus Miser guys over at NASA could do something, but I haven't seen it. And then, like you say, with SAR, or even but LiDAR, right? We don't have much space-based LiDAR other than ISAT-2 with the green laser for, looking at ice and glaciers and stuff like that. But, some of those green lasers can penetrate the water. I just don't know if they would actually be able to differentiate between plastics and water. But no, it's a great question. But I think it's it's a huge challenge. And it's just funny, or not so funny, that, we didn't know anything about this until a quarter century ago. And then nobody did a damn thing about it except for that Dutch kid, Boyan Slat, who actually, I think it was in 2018, finally got a ship out to the ocean to collect garbage and succeeded. He didn't collect much, but he proved that it could be done. So a quarter century goes by, and 6-7 billion people on the planet, and only one Dutch kid tries. Like, it's just pathetic. It's just sad. I mean,
have one comment,
either, so I'm to blame also. I just want to point it out.
Well, one comment from the audience. What about Fugro and some of the other bathymetry and hydro collectors? Do you include that with some of your data sets underneath or over the garbage?
I have never seen any of the bathy sensors doing plastic. So if somebody's got that article, I would love to see it. And I think it's a great challenge to those guys. There's a lot of great companies doing airborne stuff with bathy sensors under the Jobeltex contract with Army Corps and a bunch of different folks. So I would love to see it, but I haven't seen it, and I don't know. A lot of that stuff is done to spec. So when NOAA contracts for coastal bathymetric, or the Army Corps does for riverine, I don't know that there's any requirement to collect that stuff. So part of this stuff is the customer's got to start requiring it before you're going to start seeing it.
Well, I think so to leave the garbage topic for a second. So I think using, right. Well, just to look at other maritime sensors to things like ocean temperature to monitor the current state of the ecosystems, for example. Are you using that as another data set to figure out the ocean as an ecosystem? What is the current health of those environments?
There's a lot of correlation, right? And, we've all been through causation versus correlation and autocorrelation and all these things. So the sea surface temperature ends up as part of the kind of equation of understanding the low oxygen zones. So that's definitely correlated. And you see kind of large scale NASA and NOAA and other nations, I'm sure, are doing it also, to kind of calculate that stuff. And I think that's super important. And they calibrate those space-based sensors with their buoy sensors and stuff like that. So I think that's really critical. But the other kind of autocorrelation that I don't know, but you sit there and go, okay, well, if you put a bunch of plastic in the first 10 feet of the ocean, will it absorb more heat from the sun and warm up, or less heat? Like, has somebody done the physics or the chemistry or whatever on that? So I've got modeled garbage patches. Could we start correlating that with sea surface temperature? And is sea surface temperature going up more because of plastic, or I don't know. And I don't even like to talk about it because I'm so bad at chemistry. Like, I'm not the guy, to be talking about that stuff. But I think there's definitely room for understanding that part of the problem. These dead zones, low oxygen zones, plastics, sea surface temperature rising, and then, all that stuff just seems like a swirl of autocorrelation potentially. But I don't know what phenomenologies, what remote sensing phenomenologies you would throw at that.
No, that makes sense. I mean, but I think it's underlying a lot of things regarding the book in general, in terms of there's so much data and so much to, it's one thing to make a case for a planet of 3 billion, but right, to dive into the current status of the planet on so many levels, this to me is just an introduction to a lot of different subtopics behind everything you just mentioned. So
yeah, well, let me just keep on going. Well, I mean, before I jump to this is a little video that anybody who's seen me talk, I always use it, so feel free to take a bathroom break while I play this video. But I think people go, 3 billion, man, we're at 7.7, like, is it really a problem? And I'm going to end up talking about a more rough-hewn economics-based data set that, if you do their math, like, their number is way lower than 3 billion. So I like to point out that my number of, like, how many people can the Earth support 3 billion is an optimistic number. And I don't say that to be a pessimist. It's just pointing out that I'm not the bad news guy. Like, I feel like I'm the lollipop fairy sometime, just giving you the good news. Because it's when you stack up all the data, it gets pretty rough pretty fast. So a lot of people, they go, okay, if those are the ecoregions and that's how pristine they were, and oh my God, there's so many beautiful places on the planet, how could we possibly have kind of heaped that much human footprint on top of it? It's important to just do like a quick 100,000 or 102,000 a year burn through human history, right? So 100,000 years ago, we probably had about 1 million, way fewer than 10 million humans. And it wasn't until about 10,000 years ago, with the rise of kind of basic agriculture and basic human settlements, that you saw kind of the rise in human population. Can you hear the sound?
I'm actually surprised the sound's coming in there.
Well, hopefully the sound doesn't disturb anybody and you can hear me over it. I always forget to turn the sound off. But the thing to point out, right, is at 0 AD or 1 AD, right, you had about 178, 180 million people. And it stayed stable for hundreds and hundreds and hundreds of years. It even dipped a little bit here and there, right? Humanity, and it's not like nothing was going on. You had the Roman Empire, you had the Han Dynasty, all these amazing things were going on, particularly in the East, because of the introduction of the plow and agricultural administrative states, etc. So this is all kind of, what do you want to call it, from the archaeological record, right? So, you're talking about which phenomenology can pick out ocean garbage like that, because we're so tuned in modern days to think about sensors. But to like reconstruct stuff, sometimes you just got to do kind of that hard work of how many people were in that region, 1,000, 2,000 years ago. So, the world population stayed really stable for a really long time. And then when 1300 came around, not to make any COVID-19 references, but right, we actually had a big dip in the global population. So much so that if you go back to kind of the agriculture or the biological record, you can see that many forests regrew. But then in 1700 or so, the global population took off with the scientific revolution, industrial revolution, medical revolution, agricultural revolutions. And by 1900 at 1.6, everything then just, went nuts. So, right, this is where I always say, hey, guys, at what point do you think things went a little bit haywire? And do you think you can sustain this curve? So the reason I use this one is simply to point out that, that data, none of that is remotely sensed. It's reconstructed. And you go, wow, our footprint is huge. And go, no, that's not our footprint. That's simply where we live, right? That's where humans lived over time. So, there's a bunch of other data sets out there that have been generated by folks. This is kind of mashups. So a mashup of the historic ecoregions and, what are imperiled by human footprint. And so, this is just like kind of a little bit rigid, the same way like choropleth maps are rigid based on states, because the status is based on the entirety of the ecoregion that the data is about. So I think this is useful in kind of communicating, but it's really inexact. So I'm much more focused on the granular, because it could be in that country that it's really the urban areas are undermining the ecological carrying capacity of that ecoregion and not the farming areas. Or it could be the farming areas and there really aren't many urban areas. So it doesn't really communicate the underlying sources. But I think it's an important data set that's out there. Again, if you go to the Ecoregions 2017, just Google that, and there's a website, and it's great. You can toggle between the ecoregions and the biomes and the status of those various ecoregions in terms of how imperiled they are. And then, there's these social scientific data sets. So this is actually from a group called the Ecological Footprint Network. And I'd encourage anybody to go there. But notice this is just standard country-based stuff, choropleth maps based on some statistics. But what's important, I think, here is they've introduced a concept called the Global Hectare. Everybody knows what a hectare is. It's not an acre, it's a hectare, which is a pretty standard measure, at least for agricultural land. And, what they've been able to do is, based on the total production of the world economy, who's producing what land is committed to it. And they've been able to run some pretty sophisticated calculations on who's an ecological debtor and who is an ecological creditor. And what I like to point out here is they're very much focused on carbon, right? Who emits more carbon versus how much they sequester and things like that, which I think is super valid. But it really doesn't cover ocean garbage. It doesn't cover dead zones. It doesn't cover the impermeable surface that we have paved into the global landscape through urbanization and roads and things like that. But there's a series of maps here. You can see those little icons at the bottom of the map. So I just kind of did screen grabs. One is around ecological deficit and reserve. And these are just outputs of their calculations. One is the total ecological footprint. So you see the US and China have higher, but you see that, to the cartography nerds, Alaska is as dark as the US because Alaska and the US are one country statistically. But, the footprint of Alaska isn't as bad as the East Coast. The human footprint in Alaska isn't as bad as the footprint.
Well, you bring up a good point. So we're looking at these data country by country, and this comes down to how data is managed and looked at as countries being responsible. But at what point do we actually look at a lower level of what, maybe what cities or local municipalities are actually responsible for those footprints and dive a little bit more deeper?
No, the amen. And, so I'll just page through these, just so you can all check them out on the website at the Global Footprint or Ecological Footprint Network. But before I go to that, the guys I really love, and I couldn't really pull, I actually have a PDF of one of their articles up, but of course it's an academic article. So the maps are about this big and I'd have to zoom in on the PDF to get there, I guess. But Paul Sutton, a geography professor at the University of Denver, has a whole team of kind of geographers, remote sensors, economic geographers who took a different approach than what the Ecological Footprint Network guys did, focusing on carbon. And they focused on the paving of the planet, right? Because the amount of pavement, in a sense, is a different kind of economic indicator because, the more paved, the more urban, on and on and on. And they used that as kind of the proxy variable against global GDP. So you could see like the intense economic investment and activity here was annihilating all ecological footprint. And they were doing it at 1 kilometer by 1 kilometer squares, right? And that's something they could use Landsat and other remote sensing resources to kind of feed that analysis. The problem again, right, is that can really only go back to about 1974, or when the early Landsat resources that were on orbit. So it's kind of hard to understand where did it go from 1900 till now in terms of specific geographies. But my personal view is you've got to get very granular geographically to really understand what's burdening. Again, some countries, it is the urban area that, whether it's well-formed, well-planned urban areas or kind of informal settlements that have just, kind of seeped into the landscape. Those just annihilate the entire wilderness that might have been there. All of the flows of water get paved over. Any wetlands is just gone. But other areas, it's perhaps because of kind of smallhold agriculture that's really inefficient and just kind of wiped out the historical ecosystem so that they could feed themselves, which is great. I'm all for people feeding themselves, but you have to appreciate kind of the cumulative effect of that when the population gets so big. So maybe some countries, actually, the ecological footprint is very much due to agriculture, not urbanization. And as we all know, at least from the geography world, like every country is different. And you have to understand that. When I go back, to my kind of the picture on the book, or you see these very specific landscapes, sub-Saharan Africa, or kind of Eurasia, headed out of Ukraine, out to through Russia. There's just very different economic geography dynamics that are important to grasp. And, in other data sets, sorry, I just grabbed a whole slide. I should have gotten rid of the title here. But like this is a data set from the World Resources Institute. And there's many of these conservation organizations do fantastic research. They were asked the question, what could we replant? What forests could we recreate here? And we could question their methodology all you want, but they came up with 3 different restoration methods and found that there's so much room left that we could actually reforest, because, humanity has a way of just rolling in and destroying, nature in order to do some human activity, but then the human activity kind of goes away 20 or 30 years later. So there's plenty of these places that could be.
What's a good example of a place like that?
Well, I mean, people get tired of me talking about my upbringing in Florida, but when you drive across Florida, there's plenty of gas stations that were built in 1972 that went out of business in 1973, and it's still a gas station, and it's been an empty lot for my entire life. And I don't think it's just Florida. So there's plenty of places that.
So who would be, I think it comes down to also who would be responsible for transforming that back into some type of benefit towards the environment, right?
You, and you, all you people dialed in. I mean, we all live in cities or counties or states, and land use is a major topic. Typically, we all just kind of sit back. And unless
policy and regulation have to allow people to be able to take initiative and do that too, correct?
Absolutely. But that stuff is shaped by activism, right? The trick is, and I'm not anti-developer. I live in a suburb here, and I've got green grass, which is entirely unnatural. We chop down the forest for my quarter acre here. That has all accumulated over many, many years, many, many decades. But if you look back, this neighborhood just got built, the first house was 1934. Before that, it was all forest. So somebody said, let's chop up that forest and let's lay down street and let's put in sewer and let's make it houses. And, that's the story of the 20th century, really. And now, a bunch of us, some of us in the neighborhood go, why do we all have green lawns? Like, why aren't we like replanting, with native species? Why aren't we, kind of replanting the forest? Do I need that much green lawn? I never actually use it. But there's some geographies that I roll through that aren't having that conversation. They're just riding their riding mower on their 23 acres once a week because, they like doing it. But if they weren't, that would be 23 acres that would be, would quickly bounce back. Like
what's that urban myth about grass being the number one cash crop of the United States or the world for that matter?
Right. Well, I get infuriated. This makes me sound like I'm a real eco whatever. I mean, I've spent 20 years helping people kill people with maps. I mean, I'm a GeoInt guy that's been working with the DoD and the IC. So I don't know how you come to this. It's just you start looking at the facts and they accumulate, right? But when I start driving down a highway, you'll be on a beautiful stretch of highway. I mean, unfortunately, there's all the highway, which is asphalt, which is no longer nature. But you have beautiful trees over there, beautiful trees in the median, beautiful trees to the left. A great mapping exercise for somebody would be to understand just by taking the median and the, what do they call that, the shoulder, right? No, the excessive shoulder, beyond the one car width. If those were replanted, how many millions of square kilometer of nature would be replaced? Because it's this weird thing. You'll be driving some stretch where there is forest, and then all of a sudden, they widen the highway or something. So they killed all the trees to put the machinery. And then they decided to just mow that lawn for the next 35 years. So they're paying a guy to burn gas to mow a lawn where there used to be trees. And there were trees for the first 65 miles you drove. And there's probably trees, 35 miles down the road. But for that 35 miles, we're paying people to just do that. And you go, I never even questioned it probably until I was 40 something years old, right? Now I'm like, that's stupid. Why are we doing that? So there's a whole lot of human stupid going on that I think we don't even contemplate because it's budgeted for. It's, it's just, it's in the contract, we appropriated the funds for it. So like, why wouldn't you go do it? It's a job, and I'm all pro job too. But, sometimes you got to reflect upon what you're doing, I think.
So we've gotten this question twice now in the feed. So I'm just going to put this out there. How much do cows, bovines, affect the emissions?
A ton, actually, but it's not just cows. I think the important thing is I have a whole section kind of talking about the number of domesticated animals that we have: cows, pigs, sheep, goats, not to mention dogs and cats, right? I mean, cats are one of the biggest predators that we have out there because we let them loose and they just wipe out, all of the normal kind of small mammalian life and all the birds. And you just don't think about it, right? I mean, I've had cats, I've had dogs, and I like eating meat. But the more people we have, the more domesticated animals we have. So we've got something like 15 to 17 billion domesticated animals on the planet's surface at any moment in time. And it was a smaller number when we only had 6 billion, a smaller number when we only had 5 billion, a smaller number when we only had 4 billion. So there's this multiplying effect. It's not like how many of us are there and where are we? It's all of the animals and stuff we use to feed ourselves also,
No, that makes sense. We hear it a lot. I think it just comes down to the data. What does the data say, and where do you get the data to explain the effects of these agricultural, the animals themselves? Of course, where do you find the data for something more domesticated, like the impact of cats?
Yeah, dude, I don't know. I mean, I know that the UN put together some fantastic data, and the World Bank put together some fantastic data around the role of domesticated animals. But the maps were bad, right? The maps are broken down by country. So I think part of it is the problem with our various statistical agencies, and they think if they throw out a number, I've made my point, booyah, I'm out, I'm smarter than you. And they don't quite get that that doesn't communicate that well. And if you can't actually show the stretches of land, the very specific stretches of land where it is, then there's no way to think about on the ground local action. You know what I mean? Just go, oh, in the United States, there's a whole lot of domesticated animals. You're like, yep, you're right. You got me. Not helpful. But I think that's like that divide between the statistical agencies that are answering big policymaker questions and the geo people. And the geo people haven't yet taken over the statistical agencies. And if they did, then the reporting requirements for farmers, the reporting requirements by county or by city would be very different. But I mean, I can guarantee there's some basement office in the USDA that actually has, probably a pretty cool GIS on where the domesticated farming animals are. I have absolutely no idea who I'd go to about dogs and cats. But all I know is, all during COVID-19, we all get out of our house and we have to walk our damn dogs. And there's dogs everywhere. And there's a whole bunch of newspaper bags filled with dog poop that are in some landfill, and they're being generated 3 bags a day by every single animal. So, I mean, it's a calculable, understandable thing. But, it's just kind of nobody's job to do it. But that's part of the human footprint. I think the biggest lesson is it's nobody's real job to calculate the human footprint with any fidelity. So it's just easy to really, really ignore, if that makes sense.
No, it makes a lot of sense. And as you're going through this research for grabbing data set after data set, how have you brought some of these data sets together, overlapped, correlated them, and along the way, what were your biggest aha moments?
My biggest aha moment is that geography and GIS has not figured out time yet. And you'll find data sets that are a snapshot in time, and they may be scary or not, but you don't know if it's a historic high or a historic low. You don't know if it's part of an uptrend or if we're on a downtrend. You just see a snapshot and you go, oh, that's a lot of something in some very specific places. And so we have all these kind of, I think, fairly sophomoric discussions about, is the data accurate and is the data precise? And I'm like, I don't know, do I really care if, it's 1% of what used to be 10 years ago, if I know where it is in the trend line. So my biggest problem was finding historic data. And there have been some really great data sets. I talk about one called HYDE, HYDE, and the other one caught me off guard, so I don't have it on top of my head. It's in my book. There have been some really great, fairly granular historic reconstructions of the human footprint going back, thousands of years, like to the end of the last glaciation 16,000 years ago. And those have kind of been done to calibrate climate change data. So they want to understand where were the forests, how much tonnage of carbon were in the forests. They got cut down and got burnt. So that carbon was then put into the atmosphere, et cetera, et cetera. So there's some of that. It turns out I struggled really hard converting it because they would put it together in, for the nerds, in gridded data, right? Kind of like your multi-band spectral data, but it's in a grid. So then how do I portray it on paper? So I just kind of gave up at a certain point and tried to talk about it. I paid lots of research assistants to pull that data and slice kind of the multi-layers into different products. But then what you really want to be able to do is kind of watch them over each other, but you're coloring the grid a certain way. Anyways, we all know grid analysis and multi-band grid analysis. And so it turns out there is some old data that I would say is meaningful in certainly 1,000-year chunks, probably 100-year chunks, but the last 150 years of change isn't really captured well because the speed of change picked up so much from, say, 1850 till now that their standard chunks of their simulated or kind of reconstructed data doesn't really help. So you almost have to look at the world, kind of like that video did that I showed. You have to do it like there's that era where nothing changed that often and kind of use a certain methodology there. But that 1850 till now, that hockey stick, you need very different methodologies to kind of deal with it,
Well, I'm actually surprised to hear you say that because I think one of the questions I had regarding the data beyond the last 100 years is how do you trust the population wasn't actually a lot more than it was reported beyond 100 years just because of just record keeping?
Well, the weird thing is they actually used to, they did really good record keeping really far back. You can go back to these dynasties to their tax rolls. It's kind of like, where is the GIS bread and butter in our industry at the state and local level, right? It's the tax guys at the cities and the counties and the zoning guys, right? Because they're trying to generate revenue that somehow funds the city. So the record keeping going back, I think, on population, a couple thousand years is really, really good. Before that, it becomes more of an archaeological dig. And I think they're estimates, but it's an estimate within some pretty small numbers. You know what I mean? Like if there are 10 million humans 100,000 years ago versus 1 million, I don't really care. Right. It's kind of noise in the system.
So for the last 100 years, where do you think it kind of fell apart in terms of keeping track of the numbers and from a, compared to that, how precise you say it was?
Yeah. Well, for those of us who've done national security stuff, we kind of remember when we entered Afghanistan and you wanted to kind of see the human terrain in Afghanistan, and there was nothing. There was no Afghan ministry that had been maintaining a census. And you'll find that in a lot of conflict zones. The first thing the authoritarian wants to do is stop taking the census because it allows him to oppress minorities and do all sorts of various things. There's lots of countries where I think we actually don't have the very specific number the way we do with the U.S. Census, right? Which the U.S. Census is probably the biggest mapping agency in the United States because of what we have to do to map at an individual household level. But I guess I'd say that the UN population division was something put together when the UN came into play in the 1940s. And their estimates are pretty darn good. But it has actually made it so that we don't have the responsibility at a national level necessarily to do it all. We kind of go, oh, it's good enough, even though, Afghanistan, do we actually know how many people are there within 5 or 10 million? We had to reconstruct a lot of information in the early 2000s just to understand Afghanistan better. So I don't know if I answered what's your question?
Oh, no, I think you did. It's just, I realize that when you're looking at data sets, it's also, I think, just as valuable to record where and why there was gaps in coverage from a historical point of view, just as much as recording the actual data coming from these areas, because then you begin to understand, a lot of the lessons learned, and then actually eliminate those gaps from the data for various reasons. Because let's look at a good analogy, right? So with the current COVID-19 situation, you actually have this interesting data set issue going on right now where most of the countries are not reporting on a micro or regional level. And it makes it look like, some areas or like the United States, we're reporting on a micro and even county level. So the severity has this appearance of maybe even looking worse than it is.
No, I mean, a lot of this mapping, people kind of forget that it's an administrative function, and you either have a state agency that is budgeted to do it, or you don't have the data. So a lot of countries, for instance, that purple data in my data set, I think I may not have covered that earlier, is toxic sites. Do I need to go back up on my, where's my, I'll go back. Just say the purple there is toxic sites, right? Well, in the United States, we have an environmental protection agency, and we have a program, Superfund and others, that actually map it with, regulatory precision. Same thing in the EU, same thing in places like Japan and maybe Australia. The problem for the rest of the country, the rest of the world, was that most of those countries actually don't have those the environmental regulatory rigor that we do. So if you look, there's no toxic sites there. So the United Nations had to pay an NGO to go and do the mapping of toxic sites using a certain standard. And if you read the footnote in their data set, it always says, well, we think this is about half at best, because this is largely based on self-reporting. So I think the environmental data around toxic sites is a perfect example of what you're talking about. Even today, we don't know the totality of it because it's nobody's job to generate it with rigor, right? Number one. And two, there's no just remote sensing methodology that will let you know every toxic site on the planet, right? They're not all just surface toxins that have a spectral signature or something. But one of the most disturbing ones that I always like to point out, the environmental movement really started with Rachel Carson's Silent Spring. Anybody who's an environmental science major read that book. And she recognized early that there was this thing called DDT, right? We all know what DDT is. It's awful. It's bad. But DDT actually was used as an anti-malarial because everybody was dying from malaria. And they discovered that it killed mosquitoes. And that actually was so effective that they gave a guy a Nobel Prize for using it as an anti-malarial. Well, it took a couple more decades before we realized that's annihilating nature. And that was her book was focused on DDT, and its impacts was the birth of the environmental movement, at least, well, in the United States and around the world. So, they put a name to that called an endocrine disruptor, right? It disrupts how your endocrine system functions. That's reproduction, it's growth, it's development. And, so you go, oh, well, we solved DDT, yay. Well, it turns out there's 1,000 other endocrine disruptors that took us years and years to develop. And they kind of put it on the books for the EPA to say, where are those? Like, are they in my county? Are they in my backyard? But it never really got funded. So you'll see some bad snapshot maps of some endocrine disruptors in the United States, but mostly they're completely unmapped for a bunch of political reasons. But back to if it's not somebody's job, it isn't there. And it's really kind of impossible, I think, to reconstruct it. So if I wanted to reconstruct historically where the various endocrine disruptors were and how they spread, I couldn't even do it in the United States, let alone, other parts of the world. The only good news is less developed parts of the world, those chemicals may have been introduced either later or in smaller quantities at those dates. But reconstructing the human kind of burden through endocrine disruptors and heavy metals and stuff like that, I think that's a perfect example of it may never be possible short of kind of the administrative record. If you could find the companies that sold it, find out where they sold it to, and aggregate their receipts, and I have no idea. But it's a real problem.
So kind of trying to track our progress. And I literally mean progress in that, what are we doing to do better? Are there data sets out there to track, let's say, obviously this also highlights how many things like national parks or preservations are important globally, not just in the United States.
Yeah.
And maintaining those and adding on to those. Is there data sets to understand over time that, hey, these areas are actually increasing with growth for conserving ecologies or environments globally? Yeah.
So I'm actually going to, I'm Googling while I talk. Sorry, guys, I'm on my internet here. So the United Nations, and it's in my book, I have the maps. There is a process for creating protected areas under the IUCN, which is kind of the meta level global organization for all conservation organizations. It's a kind of a membership organization, and they have a process for kind of a treaty level process for defining geographies that must be protected. And in my book, I know it's even changed for the better since I wrote my book, but it was precious few percentage points of the Earth's terrestrial surface were protected formally under treaty, and very small amounts of the ocean. I wish I had that map up. I should have been prepared. But you can Google that. So
what's the difference between participating in that organization or a country just making some designated area for a national forest or a park?
They're kind of part and parcel of each other. If a country does it on their own, they do it on their own, and they typically will map. There's what's called protected area categories. And in them, there are nature preserves, wild areas, national parks, national monuments, habitat species management area, protected landscapes, seascapes, etc. So if a country is super proactive and they want to map their own stuff, in their GIS, and they will say, no fishing in this area, or no logging in this area, or this is, protected in a certain way. They can map them in and register them with the IUCN. The problem is those countries that don't necessarily have that conservation thing going on in their political culture, or they just don't have the institutions to support it. So then what you tend to have is like international NGOs and activists saying, this park or this geography needs to be protected because it's the last place for mountain gorillas or whatever it is. And so you have a lot of activism trying to get a country to think in a conservation way and then delineate it geographically and input it into the IUCN. So I think what you're going to see, it is kind of a ball is rolling. And this is a good news story, but I just say not nearly enough good news. So these areas do need to be protected. And it doesn't mean necessarily no human contact, but they're managed in a way that doesn't just let companies annihilate them or let people do dumb things. People do a lot of dumb things. I don't know if I answered that question, but it's the IUCN protected areas category system, and there's
I think that's good, because just like you said, tracking things temporally and tracking our progress is one thing is very important, because I've looked at the national, on several databases where there's national parks or preservations globally, even with the UN database. It's just sometimes it's hard to get an understanding of where some of these actually were established or when they've actually when more is even added without checking back maybe every 6 months or a year. Is it getting better? Is it growing? Because once again, just like you said before, there's snapshots in time. It's really frustrating to understand what's even being done.
Right. No, completely. Again, GIS is not good at time, and I'm willing to.
And a lot of people watching this might be really surprised to hear that, considering that there's a lot of temporal aspects to a lot of folks' jobs when it comes to geospatial analysis. But it is a hard problem, and we do not keep track of, or we don't keep data living enough. That's the problem.
Well, I think there's two problems. I think the historic origins of GIS didn't deal with change over time very well, right? You get a shapefile for 1990, a shapefile for 1991, a shapefile for 1992, not an object with a start date and an end date, right? And so there are some, technologies in our space that do deal with temporal better, and some that don't. And I'd say we use a lot that we've been ingrained in a lot of methods and data management methods that are predicated upon, we're not good at this, so why do it? And then remember, for years, data storage was super expensive. And so people are like, why are we maintaining all that old historic data? My mission is not historical data. But, I remember having a conversation, I won't name names, but with a general, had been a J2 in Afghanistan. And, I would ask him, what does he need that goes beyond like the current RFIs of the day? And he told the story of going to a Shura in Afghanistan where they kept talking about, the elders kept talking about Alexander and the last time Alexander was there. And he was a little confused until he found out it was Alexander the Great. Right. So the historical consciousness of the folks that were there goes back thousands of years. And they remember the last time the conquerors came, and they have stories about it. And we're walking in just looking at what IEDs blew up yesterday. And so the temporal envelope of how we understand things really depends upon the nature of the phenomena that we're trying to understand. And, the disposition of the earth and its carrying capacity is something that better have data mapped at the thousands of years and certainly hundreds of years. And, given the hockey stick of growth we've had over the past 150 years, it'd be nice to have it decadal for the past 150 years. But whose job is it to fund that work? There's only so many poor graduate students with no resources that can do pieces of it for their dissertation, right? But I think most statistical agencies don't believe the past matters and can't inform the future. And I would tell them that that worldview demonstrates their ignorance, and their adherence to that worldview demonstrates their malfeasance, and they should probably just quit their jobs. Oh, did I go negative there?
No, not at all. Just a quick comment to the audience. If you're watching the show, if you're having video issues, please send me feedback. Send the questions in terms of where you're specifically having issues. Either it's the website, twitch.tv, or you can send it through our Discord channel. I want to make sure we get that fixed for everybody in future episodes. So sorry about the intermission there, but at the on another note, I think we should also start wrapping this up as well. We've gone over an hour, so
I'm on my second beer.
Yeah, right. So with that said, I think there's a lot to cover there, and diving into the data itself, it's just once again scratching the surface of this massive iceberg underneath this story that you've told. And hell, I think the journey of trying to write this book has some value in maybe writing another book. What do you think about that in terms of the data itself, exploring, researching?
Not me. I mean, I'm happy to sit on a dissertation committee of some up and coming scholar that wants to think this through. I will say at the end of my book, I forget what the name of the appendix is, but it's the geospatial data required to kind of solve the problem. And my one regret in there is I don't really call out high resolution 3D terrain data specifically. But I try to get at kind of the categories of data that we need to understand spatially and temporally, and the scale we need to understand it at in order to not just go, oh, we have this problem, but to be able to make it analytically tractable as something that we can solve, right? It's one scale of data to recognize the magnitude of the problem. It's another scale of data to be able to solve the problem. And I think to drive advocacy at a local level and to drive action at a local level, we have to bring this stuff down to a much more granular scale. And I'd encourage people to just read that chapter and give me feedback, or it's an appendix, and give me feedback on that. But if people are trying to generate, things to do during COVID-19 and you want to map things on your own, feel free to tweet at me at Planet Tucker. Well, that's 1T, or at Planet 3 Billion. And I'm, be happy to work with you. I've had folks from various public agencies say, what can we do? And given that that ecoregions data set is the Forest Service and the EPA, adopted by the world. So if you're sitting at a public agency and you don't think what you do matters, then think harder about, what data set you could be creating to help us understand our planet in a better way. So, because what you do could and should matter if you don't think it does today.
No, that's great, Chris. I want to appreciate you coming on, talking about the data behind the book, A Planet of 3 Billion. My last, I said probably, I don't know if I've said this before. I don't know if I'm drinking, but my last question for this is, what data set have you been missing throughout all this that you feel like you want to see the most? You already talked about going down to the granular level, but what data set do you feel like, man, I really wish I had this to complete the picture? Maybe not complete the picture, but really fill in some of the gaps.
Yeah. A couple, and I guess I'd say they're related to going into the ecoregions data set. One of my little throwaway lines that I always say is, when a species goes extinct, they don't go extinct on the entire planet. I mean, they do because they're extinct, but they're going extinct in a specific ecoregion, right? There are no polar bears in the Kalahari. And we'll hear like, oh, another extinction, but nobody ever maps the extinctions in the news. And, are they mostly happening in specific regions because of the human footprint? That's kind of what I would guess, right? So I would love to actually see change over time in terms of the extinctions. And if this data set exists, please just tweet me. That shows kind of historical reconstruction of within the ecoregions where various species have gone exist and what the kind of historic field was. It might have been a migratory animal, or most animals migrate to some extent, but like a cross-continental migratory animal or within some specific ecoregion. I would love to see the history of those extinctions, but then I'd also love to see the history of the introduction of domesticated animals. Because there's a lot of debate like around in the old Fertile Crescent, it's no longer fertile. Like, why isn't it fertile? And part of it is we introduced ruminants, goats and sheep and whatever, that, once you cut down a tree and anything starts growing, a ruminant eats it. So we had many places between the mix of humans kind of deforesting or kind of cutting down bush and engineering floodplains and then introducing ruminants that just annihilated the entire area. So I think how did we introduce those domesticated animals and how did we annihilate species, I think tells you a lot about how you're impacting the carrying capacity of the ecoregion and how in turn that impacts us as a species.
No, that's some great feedback there. And I keep on saying this, but this one just came in, and this is really going to be the cut off this time.
All right.
But like I said, we still got people watching, so that's good.
We can episode 2 of this, man.
Right. So the New York Post recently just put out an article related to the sun has entered a lockdown period, which could cause a freezing period, which is equivalent to what happened in between 1790 and 1830. I don't know if you saw this or not, but I guess they wanted to get your opinion on this, where temperatures plummeted by up to 2 degrees Celsius over 20 years, devastating world's food production.
Right. I have not read that article. I will go hunt it down. I will say, there are legitimate instances over the history of the world where solar events and they call it the Earth wobble have been isolated mathematically. They know with rigor that those things existed, and then they try to correlate those with the events. And I think like the transformation of North Africa many thousands of years ago, from being a lush green system of lakes and rivers and its conversion into the Sahara. Some folks point that is tied to an earth wobble, but there's also plenty of evidence that shows the introduction of kind of human cultivation took what was lush but marginal and made it so that it can't grow back. So, I feel like there's sometimes a political agenda where folks say, yeah, but the Earth's going to cool, so you don't need to care about global warming. And all I'd say is, like, wouldn't that be nice? It's kind of like the folks that say, when Mary Shelley wrote Frankenstein, there had been a big volcano event, and it had put so much ash into the atmosphere that there was cooling. Well, planning on a volcano eruption is not a strategy. I guess I'd kind of put those in a similar category. So,
well, it doesn't change the expansion of the human footprint anyway.
Yeah, the human footprint is still annihilating the planet, and the amount of carbon that we're generating is fundamentally acidifying the ocean, which will change the ocean chemistry, wipe out the phytoplankton, which generate 80% of the breathable oxygen for humanity. So, yeah, still an issue. But yeah, the earth wobble is a real thing. And I try to address that in the text of my book, where, things change for a lot of different reasons. And I would say the early climate change work by James Hansen, Wally Broker in the 70s and 80s actually took that stuff into account and was pretty intellectually honest about it, even though the debate in the newspapers and, TV these days may not be. Any more questions, man?
No, I think we're going to cut it off officially at that point. So we're all done. I appreciate once again joining us, Chris. And I want to also remind everybody we're partnered with the American Geographical Society with Project Geospatial and Geospatial Frontier. Tune in. We're going to have this recorded video posted hopefully by tomorrow morning. I have to actually process and edit this thing. So with that said, we look forward to having a world of sessions on this week. We have a panel going on tomorrow morning. Hopefully you can tune into that, as well as several other great presentations. So check out the schedule at www.geospatialfrontier.com/schedule.
And thanks to you, brother. Thanks for putting this on. It's a great resource for the community. We appreciate it.
All right. Well, this is Adam Simmons with Chris Tucker signing off.